Missing data often carries signal. In clinical records, a missing test can indicate disease severity. Ignoring this assumes random missingness. Graph neural networks like GRAPE represent incomplete data as bipartite graphs, connecting observation nodes only to observed features. However, GRAPE treats samples with identical observed values, but different missing patterns as equivalent. It discards the information in the missingness mask. Pattern-Aware GRAPE addresses this by explicitly encoding the missingness pattern into the observation node, embedding prior to message passing. They evaluated 4 encoding strategies: learned embeddings, frozen random projections, statistical summaries, and hierarchical compression. Across 7 UCI datasets, pattern-aware methods improved balanced accuracy by 17% and F1 macro by 22%. Gains were heterogeneous, ranging from 80% on the annealing dataset to minimal improvement on hepatitis, confirming pattern encoding is most effective when missingness is structured. 2 technical findings stand out. First, frozen random embeddings achieved a balanced accuracy of 0.65, nearly matching learned embeddings at 0.663. This suggests distinguishing between patterns via distinct representations is more valuable than optimizing them end-to-end. Second, explicit pattern encoding reduces reliance on attention. An ablation study showed simple mean aggregation with pattern awareness matched attention-based variance. This enables elimination of attention mechanisms, reducing computational complexity while retaining the predictive power of the missingness signal. For tabular data with informative missingness, encode the mask. Surprisingly, simple random projections may be sufficient.